Welcome to Session 25 of Grade 11 Advanced Algebra and Precalculus. Today we study rational inequalities. The focus is to solve rational inequalities using sign charts that include zeros and undefined values. By the end, you should be able to do these three things. 1. List numerator zeros and denominator zeros. 2. Test signs on intervals. 3. Include zeros only when allowed, and never include undefined values. A rational inequality has two kinds of boundary points. Numerator zeros make the expression equal 0. Denominator zeros make the expression undefined. Zeros may be included when equality is allowed. Undefined values are never included. Solve x minus 3 over x plus 2 greater than or equal to 0. The critical values are x equals 3, where the numerator is 0, and x equals negative 2, where the denominator is 0. Testing intervals gives positive on negative infinity to negative 2, negative on negative 2 to 3, and positive on 3 to infinity. Include 3 because equality is allowed, but exclude negative 2 because the expression is undefined. Multiplying both sides by x plus 2 would be risky because x plus 2 changes sign depending on x. If the multiplier is negative, an inequality sign reverses. The sign chart avoids that trap by testing the expression directly on intervals. Your turn. In x minus 1 over x plus 5 L, which value is never included? Pause the video and solve it. Here is the solution. Work line by line, then check the final answer against the original question. After the video, complete these three tasks. Copy the model from the lesson, solve each one fresh, and write one error log sentence about the mistake you are most likely to make. Let's recap. Rational inequalities use zeros and undefined points as boundaries. Numerator zeros may be included when equality is allowed. Denominator zeros are never included. A sign chart protects you from unsafe multiplication. Before moving on, write one sentence. The step I must protect is. That small reflection turns the video into real self-learning.